In the early 1800s, astronomers were puzzled by a peculiar observation. The planets seemed to be spaced out in a predictable way, following a pattern that was almost mathematical in nature. However, there was a large and conspicuous gap between Mars and Jupiter that defied this pattern. Could there be a missing planet in this gap? Some astronomers believed so and set out to find it. In 1801, Italian astronomer Giuseppe Piazzi discovered a celestial object in this mysterious gap. This object was named Ceres, and at first it was hailed as the missing planet that astronomers had been searching for. However, as time went on, more objects were soon discovered in the same region, each adding to the mystery. It became clear that these objects were not typical planets, but something entirely different. This area, filled with numerous rocky bodies, is what we now call the asteroid belt. It's a vast region filled with rocky bodies of various sizes, from tiny pebbles to large boulders, all of which are remnants from the early solar system dating back billions of years. But how did this cosmic junkyard come to be? The story of the asteroid belt is a fascinating chapter in the history of our solar system. One early theory was that a planet did exist between Mars and Jupiter, but it was destroyed in a cataclysmic event. This is known as the disruption theory. German astronomer Heinrich Olbers, who discovered Pallas, another large object in the asteroid belt, was a proponent of this theory. Olbers believed that a planet, which he named Phaeton, exploded millions of years ago, shattering into pieces that became the asteroids we see today. This theory was further fueled by the discovery of more asteroids, such as Vesta and Juno. However, over time, the disruption theory lost its appeal as scientists learned more about the asteroid belt and the early solar system. The prevailing theory today is the accretion theory. This theory suggests that the asteroid belt is not the result of a planet's destruction, but rather the leftover material from the formation of the solar system. Billions of years ago, our solar system was a swirling cloud of gas and dust called a protoplanetary disk. Gravity pulled this material together, forming the Sun at the center. The remaining material coalesced to form planets. However, in the region between Mars and Jupiter, the gravitational pull of the giant planet Jupiter prevented the formation of a large planet. Instead, the material remained scattered, colliding and sticking together to form the asteroids we see today. Section 4. Cosmic rubble. The asteroid belt lies between Mars and Jupiter, a region populated by millions of rocky bodies known as asteroids, ranging in size from small pebbles to dwarf planets. This vast expanse of space is a fascinating area of our solar system, filled with remnants from its early formation. Ceres, the largest object in the asteroid belt, is so large that it's classified as a dwarf planet. It was the first asteroid to be discovered back in 1801 and has intrigued scientists ever since. It's about 940 kilometers in diameter, making it a significant object of study. Other notable asteroids include Vesta, Pallas, and Hygiea, which, along with Ceres, make up about half of the total mass of the asteroid belt. These bodies provide valuable insights into the conditions of the early solar system. Despite popular depictions in science fiction, the asteroid belt is not a crowded, dangerous field of space rocks. Instead, it is a vast and mostly empty region. In fact, the distances between asteroids are vast, making collisions relatively rare. This sparse distribution allows spacecraft to navigate through the belt with minimal risk. Section 5. Journeying through a shooting gallery. The idea of navigating a spacecraft through the asteroid belt might seem daunting, like dodging bullets in a shooting gallery. The sheer number of asteroids and the speed at which they travel can make it seem like an impossible task. However, the reality is far less dramatic. The asteroid belt is not as densely packed as one might imagine from science fiction movies. Spacecraft have successfully flown through the asteroid belt without incident. The vast distances between asteroids mean that collisions are extremely rare. Pioneer 10, launched in 1972, was the first spacecraft to traverse the asteroid belt on its way to Jupiter. This groundbreaking mission paved the way for future explorations. Since then, several other missions, such as Voyager 1 and 2, Galileo, and Cassini, have safely navigated through the belt. Each mission has provided invaluable data about our solar system. The successful passage of these spacecraft through the asteroid belt highlights the true nature of this region, a vast and mostly empty expanse punctuated by remnants of the early solar system. It is not the chaotic obstacle course it is often portrayed to be. It is a cosmic time capsule holding clues to the formation of our solar system and the planets within it. These ancient fragments offer a glimpse into the past, helping scientists understand the origins and evolution of our celestial neighborhood.